lecture first and then move on to the lab exercise. Today's topic, advanced 3D modeling and rendering, first class. Today we need to review what we have walked through from the course, and before moving forward, especially next semester, we're going to review geometric modeling in terms of architectural design, as well as some visualization technique. Okay, so I put this schedule where we are again. Today we're gonna review your final plan one by one or team by team, and next week, as scheduled, we will have midterm exam. Okay, next week. I heard someone declared today is the midterm exam, but next week. Okay. Also, I need to get your final project progress report 2 more weeks, next step to next week. So you need to bring your ideas, your development, your work have done, even by hand, whatever it is, and then gonna have final project presentation. You don't need to do anything, just bring your final digital architecture image, and I'm gonna put on the screen and get some critique, sometimes mostly criticism from others, not presenters. Okay, so whatever you show for your final project, probably it's going to be visually effective so that others can recognize what it is. Okay, even if it's one single image. So that's why I showed you lots of time graphical images done by professionals, mostly from idea design book. Okay. Also today I like to show you some more examples, and we're gonna walk through as a review. So here I list what to do today, some idea and concept development process using examples done by professionals, and move on to some series of lab exercises. Only 4 lab exercises, 1 and 2. They are some mental array or V-ray, same. Rendering based techniques, how to reduce time, how to activate some advanced features in renderer, and you need to submit your own office design, okay, as a submission requirement for the lab exercise number 4. Also, I want to show you how to set up your concept and how to develop, and how quickly and easily you can visualize using this software at this time in this semester. That's 3D Max Design 2015, right? Okay, let me list up briefly what we have been walked through. Okay, here are the things what you have learned from this semester. Firstly, CAD and graphics fundamentals, and also the major topic, major content, major subject for next week's midterm exam gonna be number 1, CAD and graphics fundamentals. Okay, some from others, some generic function or features in Max or mental array, and some modeling issues, but mostly fundamental theories, background issues. Okay, so we used 3D Max Design 2015 as a CAD and computer graphics platform engine tool, and we have learned mental array and V-ray first. Usually you need to learn how to model your geometry and then move on to some technical issues in renderers. But for bringing your attention, a little bit more attention to the course and get you a better learning curve, I introduce you some renderers first, so that you can create very fancy photorealistic images without any background knowledge. And then recently we walked through some geometric modeling, as well as some AutoCAD plan-based architectural modeling. Okay, so what's next? And what's next? That's the question. Probably in your head, something like this question. gonna be arise. So firstly, elaborated and skillful CAD and graphics technique you need. How? You know how. Spending more time for training, okay? In the limited hours in our course, in our class, I put more emphasis on teaching you how and why, actually, not just one by one, step by step process to make or to visualize something else. Anyway, especially using 3D Max and SketchUp, Rhino, whatever it is, using any type of 3D graphics tool, you need to elaborate your skills, okay? That's first step. Second step is, okay, even if we have learned very cutting-edge advanced graphics tool, 3D Max Design 2015, that's the latest version of that very famous and well-known software, 3D Max. The geometry you just created are all dummy geometry. In other words, they are just polygons, okay? Lines, vertices, edges, or so-called meshes, editable polys. Not design object, design element, okay? You are designing table, you are designing specific interior design objects or architectural building element, such as ceiling, wall, window, and so on. But in 3D Max, all of them are just polygons, okay? That is why I say 3D Max geometry, even if they are architectural building model, they are dummy geometry model. Of course, next step is something smart CAD and graphics. What is that? I can say briefly, one of them is building information modeling, BIM, okay? That's not the major topic this semester. Probably next semester, you're gonna learn some BIM theories and software such as Revit, Vasari, parametric design. When you learn that kind of software, you can declare really it's dummy when you learn this kind of advanced smart CAD and computer graphics system for interior architecture design. You may know how it's not easy to say in that way, but anyway, that's why I'm saying 3D Max design. I don't like that much. It's just dummy geometry creator, okay? But it's very powerful to visualize something, to express, to represent your design concept and an idea using that polygons, okay? That's today's topic and the overall subject of this semester in this CAD and Graphics 2 class, okay? For bringing and paying more attention to developing your concept and idea, I like to show you some more examples from that idea design book. As I introduced you before, the content list of this book categorized by primitive geometry, not building type or building purposes or objectives. Okay, usually if this is building design, one easiest way to classify those buildings are building types: schools, commercial buildings, and some public buildings, and some libraries, and so on. But this book classified the design category using polygon, circle, box, organic form, tower group. I told you those are primitive objects in 3D graphics tool, okay? Because this is idea design book, I'm not sure how many of building designs gonna be realized in real world. But anyway, the shape of those buildings are within those classification. So this is one of the tower, and the name Scott's Tower. Okay, simply these are some preview of your final project, as well as the examples that I show you from DA award-winning works. Okay, you can make only this single image or this one. Even if it's just single image, whatever it is, from your studio work, from your scratch idea, whatever. Anyway, you don't need to say anything. Just popping up your final image like this, and your friends, including me, gonna be expressing what it is. So what you need to do is put your idea, how you develop your simple idea into this kind of final structure. Of course, this is tower, high-rise building. You don't need to do that. You can focus on very small size building interior or commercial buildings entry floor or entry area or some specific furniture, layout, whatever it is. Anyway, most important thing is how we can recognize that design in terms of design concept and its progress to develop into this kind of final image, okay? So all these examples done by something professional. Let's take a look at concept diagram. It's not easy to figure out the purpose of this building or the major objectives, the concepts, philosophy, whatever, but we can recognize this is something unique space within this building. And the geometry and the structure for sky view and urban view. Some two different type of views using this kind of zigzag structure. Stacked box, but something different. And something different views, okay? And then in terms of final output building design, anyhow, designer's intent is something like this, and it could be represented in this way, okay? So I'm not talking about the function or some area or special program, whatever, from this building. I would like to keep focusing on the visual effect and efficiency of information transferring to others, to audiences, without any background knowledge about this building, okay? How about this one? International Plaza single tower. There is a tower and some series of scattered small buildings, but it looks a little bit weird. Some building is above without any structural stability. But anyway, we can recognize these are some design alternatives, including some other examples. Stacked boxes and a bridge connected between those two different buildings, and the low-rise part can be seen like this way. Anyway, we can recognize the shape and some geometric connections or some relation between those two buildings and so on. So I like to show you some visual effect and how designers can deploy their ideas to audiences, readers of this book, okay? The next example, MVRDB, probably you may know MVRDB. They are one of the world famous architect group. Anyway, the building of this design looks very simple, just box, cubic shape. But as you noticed, the surface material or surface geometry is looking very unique and something different from other simple shape. Also, concept diagram combination. This one shows some existing buildings, structure, and some primitives, yellow, two boxes and one cylinder, one cylindric shape object, and some subdivided elements. They can be appended on top of existing structure. And then we can generate this building. That is something about building mass, structure, And surface design can be seen in this kind of 3D representation, 3D visualization, okay? So keep focusing on visual effect and how you recognize its design concept or development and final outputs. Okay, how about this? Also a simple box shape, but something different. Usually box shape is thin wall envelope. So amount of void inside, something like this building, we can use as an interior structure. But as you see in this rendering, in this visualization, interior space mostly filled with something like those structure for designer's intent. We are not sure about this material or some details, but anyway, as you see this diagram, now we recognize there are 4 half-dome shaped spheres, okay? But simply Boolean operation, A minus B. In this case, 1 single cubic box minus 4 half-dome cubic shape. And then you can finally get this kind of void space interior. So from very primitive objects, but based on the process, I mean some A minus B simple process, we can generate something like this mesh shape, but that is too simple. So something unique material filled in this solid space, solid part of that mesh gonna be looking like this. Anyway, we can recognize design process, concept, how primitive geometry can be affected in the final object like this way. And how about this? When you see this kind of rendering scene, okay, it looks very colorful and the same sized cortinal windows. And so what? That's it. But if you see this kind of 2D geometric diagram as well as pop-up hotel, the title of this project, you can recognize this is a kind of tray for transportation. And there is a box, probably specific unit shape. And take a look at this truck. This one for 1 single container. Container has specific dimension. So 3 by 12 number of those box shape gonna be 1 container box. So 1 single container can be transported by this truck, and this truck can contain, 1 truck have 36 module, okay? 1 single module have some specific dimension, like this way, can be delivered, transformed, or anyway, can be reused for different purpose, design, goals. Anyway, now you can recognize this 1 single facade shape gonna be the same dimension from this shape, okay? Of course, we need to take a look at a little bit detail, especially from this book, but now I like to show you some visual effect for this project. How about this module? The same module, but a little bit different. This 1 single module for 2 people, this one for 4 people. Take a look at this one. It has, in this section view, we can recognize there is stairwell, and this one could be 2-story module, and floor plan plan for 2 people, represent some furniture and desk and some elevation structure like that. Plan for 4 people, a little bit bigger than this one. But anyway, 2 toilets and a little bit different structure and elevation, something like this different structure, and some iconic symbols to represent specific function or specific objectives from this one. That kind of module can be transported by this kind of train comparatively easily, okay? And take a look at the title of this project, Instant House. Okay, now you can recognize this one can be sort of, it's not a lifetime building, it's kind of instant purposed, special purposed building for 2 or 4 people. The subname is Instant Lung. You know what is lung, okay? Lung, this kind of organ, okay? Human body organ for breathe. So we are not sure the functionality of that lung system, but anyway, it's related to something ventilation system, okay? Air ventilation, air circulation system. We are not sure, I'm not sure what it is in detail, but at least we can recognize, thanks to the title lung and this diagram, we can imagine this one is special purpose ventilation system or something more, okay? And how about this? When you see this kind of final render scene, this one looks like some co-housing apartments, some rectangle shape, nothing that special. It's not easy to figure out the site plan, but take a look at this isometry. Now we can recognize certain type of modularized system, okay? One single cubic box can be composed of very different variation. How about this one? Now we can recognize some rectangle shape, half cut, and another half cut, more half cut, they can be make some variation. And eventually we can make this kind of building mass from this rectangle shape, from very simple structure, simple geometry, into converted into this kind of complicated combination, okay? So this one is final output. Somewhere in this, you can place your camera somewhere around here and then take this picture, partial, very small portion of this design. But thanks to this kind of process diagram, we can recognize how it can be generated. Next one, Busan Opera House, okay? So when we see this photorealistic rendering scene, okay, it looks very complicated or specialized building facade, but building mass design is just a cubic box, nothing looking special. But actually, take a look at this lower level structure, looks something organic shape, standing this box shape. It's not easy to figure out the concept, but let's take a look at this diagram. Busan is famous to this kind of container vessels, and container looks like the combination of those cubic boxes, okay? So thanks to these cubic boxes, we can generate this kind of container vessel, and this one, simply say, this is one huge size of container. And this is vessel. Take a look at this one. Containers, and there is a vessel which has this kind of shape because of that vessel shape. So the cubic box from containers and this shape from vessels. So now you can recognize this is very intuitive and kind of straightforward, okay? This is located in Busan. So very, even if it's straightforward, anyway, designer's concept can be recognized by this kind of public, general people, okay? And very plausible. How about this one? Next example shows you some triangular shapes looking like this sharp tops. It's not easy to recognize in this level. It's looking zigzag and so on. But let's take a look at this diagram, additional diagram. Even if it looks like a 2D diagram, which has some freehand drawing like structure. At first, there is a primitive triangle shape. You can cut it and stack in this way and 90-degree rotation. And then we can generate this series of triangular shape. Okay, take a look at this one. There is a block, there is a box, cut in this way and make some perpendicular angles and 90-degree, okay? 90-degree rotation in different ways. And then we can generate something like this structure, originally from rectangle shape, okay? How about this? In its exterior scene, it looks very typical, very something boring mess of this building. But interior scene looks very dynamic and complicated. Take a look at this simplified diagram, also looking like freehand drawing. Anyway, there is a rectangle shape, triangular shape, because of some gravity or something different type of force to affect the shape of this building. So triangular shape can be generated. And take a look at rotation, but not total rotation. The internal rectangle shape can be rotated, as well as triangular shape too, so that we can generate something totally different inside, okay? Even if building exterior looking very typical and simple, boring, interior can be variable in this kind of very simplified differentiation, okay? So it can be represented in this way. Of course, it's one of the done by professional architect. And the last example is, I think this one is very unique and very, very effective in terms of design representation, including design idea. Let's take a look at this triangular shaped building. There is a space which has some void area because of some cut out mass from this triangular shaped building mass. But we are not sure the purpose or the reason why it is looking like that. But let's take a look at this simple diagram. Also rectangle shape, two rectangle shape can be generated in this way. And take a look at the title, mosque. Probably something religional building. This is conventional mosque. There is a dome shape, religional and very large scale, and some typical type of building shape in terms of its elevation. And people are outside of this building, not easy to access. But simply invert the concept of this geometry. So now we have some solid structure in this shape and void interior. And people, we can bring them inside of this structure, okay? But actually take a look at this area. This area, is this building exterior or interior? Technically it's exterior, but I think it's not easy to differentiate whether it's interior or exterior, because in terms of its functionality, this is building inside according to this concept. Bring people from outside to inside of building. But anyway, technically it's outside. It's not easy to differentiate. Thanks to the designer's intent and designer's concept development, this building can be dramatically represent very well their ideas and developments and so on. So that is why this building looks very unique and very visually also effective, okay? So what we have walked through are some visual representations for design. So how to make this kind of things? That is why we learned SketchUp or 3D Max or some other geometric modeling tools. But actually, let's get back to the fundamentals of as a review. So what is this? This is fundamental and conventional representation in 2D, okay? This is front view of a chair. Okay, it looks like a chair, but it's not easy to figure out the shape. How about top view? Top view looks kind of weird. Bottom view also. But now we can recognize when we see this kind of left or right view elevation, okay? That is left view. So using those 5 different plan views, we can imagine it's 3D views, okay? This is conventional 2D based, plan based representation. But now we use this kind of 3D representation. But actually there are too many lines. So this is hide, hidden line removal. Hidden line means, okay, those lines supposed to be hide because this is solid wood structure probably. So we cannot see this kind of line. So this is so-called wireframe visualization. Wireframe visualization is one type of rendering, but it's very primitive, very elementary rendering, not photorealistic rendering. This is hidden line removal rendering, okay? Hidden line removal rendering, so that we can recognize easily. So in this case, 3D view is effective to recognize the holistic shape of this chair. But to recognize the dimension or thickness or structure or proportion and so on, we need plans, okay? So in terms of conventional drafting, we usually draw this kind of diagrams, this kind of plans, as well as this kind of standardized 3D visualization, axonometric or isometric, okay? Typical 2D representation. But 3D surface model, such as SketchUp or 3D Max, we can directly generate this kind of 3D object. Based on this 3D object, we can easily make plan, left, right view, top view, bottom view, or any type of standardized 3D view, including amount of different perspectives, okay? But actually, we didn't get this 3D solid model, parametric model, building information model. But anyway, they are the subject for the next semester. Anyway, 2D drafting based representation, mostly done by AutoCAD, but we have been walked through 3D surface based model. So all these representations are one part of 3D model. So if you generate 3D model directly, you can easily generate all the 2D drafting standardized plans, okay? So in here, it's 3D modeling, okay, not drafting. But I told you before, the term 3D modeling, at least in this semester, it's 3D geometric modeling, okay? So let me show you this CAD history again as a review. This single page contains amount of historic events from around 40 years ago. The first thing, when we believe design is a drawing of the product, I show you that front view, elevation view, left view, right view, top view, that kind of drawings, if you draw that kind of formal drawings, around 40 years ago, we believed that is design, okay? At that time, 2D geometric drafting is okay, such as AutoCAD. But next stage, we invented geometric surface-based modeling tool in 3D, SketchUp, 3D Max, and so on. So, okay, designers believe that 3D surface-based model required for design representation. But you know where we are? We are in this stage, okay? 3D Max. Simply, this is kind of preschool, elementary school, middle school, high school. university level. Even if we are in university level, we still get reached to this level. Anyway, we are still in some certain elementary level in terms of modeling buildings. Anyway, this is 3D Max. Next stage, solid modeling and parametric modeling and building information modeling, okay? So usually building information modeling contains everything. So parametric modeling, solid modeling, BIM, we're gonna learn all together next semester. But still, our focus is on surface-based 3D modeling. Why surface-based 3D modeling? It's very efficient in visualization, only for visualization, okay? Only for design representation. Series of examples that I show you today, as well as last week, their main goals is just design representation because it's still in idea stage, not for actual construction, okay? Main objective for those series of visualization is just visualization, okay? Not real construction or construction management or facility management or structural analysis, nothing, only for design representation. So in terms of design representation, your design studio work as a student, we are still focusing on this stage for design representation. So 3D graphic software interface review. As another review, I like to quickly show you this one again and then move on. 3D Max Design 2015, that's what we have learned this semester. Interface looking very complicated because too many options, too many buttons we can click. That is why it's hard to learn. We are struggling. But I told you we don't need to stick to graphical user interface issues. There is no time to recognize which button is your specific function. Memorizing the sequence of clicking buttons, that's kind of temporary, not the major thing you need to learn. What I'm telling you always is no need to memorize sequence of clicking buttons. Instead, you have to capture the behind the technology and the process. I know it's not easy, and eventually, anyway, you have to know which button you have to click. But my focus is priority is not on that kind of user interface issues. That is kind of second, third priority. Top priority gonna be comprehend your technological aspects of those tools, okay? So that is why I introduced you this one before, some GUI-based and NUI. Our 3D modeling tool supposed to be NUI, touch-based, because they are 3D object, but we are using 2D screen. Your smartphone, laptop, even if they are cutting-edge devices, they are not holograms. They are 2D projected screen, okay? But your object going to be 3D. So it's not tangible. The gap between 2D screen and actual 3D object hinder your learning curve better. So that's not easy to learn. That's why I introduce you some more examples. There is amount of more ways to create your own geometry, not only by using 3D graphic software such as 3D Max. It's not easy, but in the future, probably near future, you can generate your 3D object precisely, effectively, quickly, in very intuitive way. Laser scanning is one example, but we don't need to use laser scanning. Actually, there is, I told you 1-2-3D Catch before. 1-2-3D Catch PC version also very powerful. You can use this kind of smartphone to take pictures, series of pictures, not the face of your friend, this kind of complicated shape object you can take series of pictures and load that into cloud server of Autodesk and open it using your PC version 1-3D Catch. And then you can generate editable poly 3D mesh of this structure, okay? Or your friend's face like this one. But this chair or the surface of this interior, this room, can be captured easily by clicking your snapshot buttons. But anyway, PC version will generate this kind of meshes, editable poly, directly importable into 3D Max, okay? Please try to that, and I'm going to show you the demonstration later, okay? So actual reason is here, why 3D graphics is hard to learn. Ray tracing, bump mapping, UV mapping, sweeping, lathing. Without understanding what are these, learning 3D Max is equivalent to memorizing the order of clicking buttons, clicking sequence. Just GUI interface. It's not top priority, okay? Top priority are here, that is here. So that's why I always put emphasis on some theoretical background. Okay, after we're gonna have a quick break and then move on to the rest of lectures and then lab exercises, okay? 빨리 끝내고 랩 엑서사이즈 바로 시작할 테니까. 오케이. Okay, let's get back started. Another review, 3D modeling. But I told you 3D modeling here means 3D geometric modeling, okay? Not information modeling, especially building information modeling. It's geometric modeling. In other words, whatever you create, they are just polygons, okay? Lines, edges, points, not walls, floors, furniture, and so on. They are just geometry, okay? So in terms of geometric modeling, let's review quickly, and I'm going to introduce you today's lab exercise number 4. In terms of geometric modeling, how to quickly visualize your design thanks to what you have learned. 3D Max modeling, 3D Max rendering technique, okay? So geometric modeling, here is subcomponents of geometry: vertex, edge, face, polygon, surface. So modeling 3D object means creating an object in terms of geometry, such as this kind of box shape. This box is one of the primitives, okay? And modify again and again. Very recursive, iterative, time-consuming process, okay? Very hard to do. Modify in 2D geometry. If you modify this 2D, this 3D box shape gonna be changed, updated. If you use more segments and inset, you can change a totally different shape, okay? That is modification process in terms of geometric editing. What kind of primitives are there? How to create 3D object from scratch, from nothing. First thing is primitive, including this kind of teapot. This is one of the primitives in 3D Max, that's what I told you. Donut, cylinder, box, sphere, and just 2D or just simple line or just 2D shape geometry, they are all primitives. So why they are important? Thanks to that kind of primitives, the first method, representative method making 3D is extrusion, okay? So simply think about this is AutoCAD plan for your design, floor plan. Last week, we have learned how to extrude this one into specific dimension, height of that building, so that we can create 3D building walls, okay, and some more objects, architectural elements. This is the first one, extrusion. The second one, lathing, revolving. Also, this kind of section profile is very important, as well as this one. In extrusion, anyway, we need 2D section profile. Also, this one requires section profile, but it's going to be revolved. And then we can create this kind of specialized 3D shape. The third one, probably the most important thing, is sweeping. Also, number one, section profile is very important, and its path, okay, so that you can generate something like this. Another application, another one. Next one, others, something like this, morphing, using different section profiles, and also constructive solid geometry, CSG, so-called Boolean operation, okay? A minus B, A union B, A plus B, A intersection B, and so on. They are some operations, operation-based geometric creation. So according to that kind of series of geometric editing, modifying mechanism, what can I do? What we have to do? Let me show you an example. By using 3D Max modeling and rendering technique, so-called design representation perspective, okay? It's, of course, geometric modeling. In other words, there is no need to be a smart model, okay? You don't need to model entire building. You need to keep focusing on specific building shape, building interior, specific architectural objects, and so on. In terms of geometry, even if it's surface, that's okay. Why not? If it looks like totally same to your concept, your design product you want, okay? So let me show you one given scenario. Workspace design, concept development using 3D visualization, especially using 3D Max. I would like to bring your attention to actual design project, especially early phase of design, how to visualize, how to represent your design concept and development in very efficient and very quick, easy way using 3D Max, okay? Let me show you this diagram again. Scenario, use scenario in terms of technical aspect. The first thing you have to do is defining your universe, okay? Okay, now I'm gonna design office interior. There is no chimney, there is no building entry, there is no elevator, okay? We don't need to model them, just a simple box we need, especially inside of that box. In that case, we don't need to model walls, windows. Instead, we can simply make a box and place your camera inside of that box. And then we can recognize that space is a specific interior of a building, office building, one of the office area, okay? Anyway, that's my universe. So defining your universe first, and the geometric modeling. Firstly, modeling universe. That's what I introduce you as an example. Just box shape, just one single box is enough in this universe, okay? That is so-called environment. Also, we need to design elements. Today, you can simply draw your posts or some organic shape. Let me introduce you in lab exercise hours. And the easiest thing you can do now is importing existing furniture, existing design element from 3D warehouse or designed by your friends, whatever, okay? So planes, walls, actually we don't need walls today, just box shape, okay? And design elements, mostly 2D sketch-based extrusion or some 3D given model and imported. And rendering, we already experienced powerful mental ray. Thanks to mental ray's material mapping, there are amount of Autodesk material, hundreds of material, very high quality and well-defined, and photometric lights. Very easy to install, easy to control, but looking very realistic. Also, powerful camera. You know how to control focal distance and some additional effect, including today's lab exercise. And simply render it, okay? And then you can generate very early phase, high quality image for your design representation and retouching in 2D Photoshop or others later. According to this process, let me briefly introduce you a quick representation of design. Let's take a look at reference images. Here is the concept. Okay, this is a small office for an IT-based design company, such as, just simply imagine you are working some Facebook office or Google office, something like that, okay? So Prezi, Flash, e-content based, probably game development, software company, whatever, small size company. So we need to get feedback frequently from users, especially through Facebook or Twitter, whatever. So we need a screen. We need amount of communication media. So media post, that's one of the concept words, and connect to the network and touchpad devices, wall mount touchpad like this screen, and so on. That's the major concept, okay? So how to represent it? So we need to search reference images, something like this, okay? Something like this, tangible, actual wall mount screen, but it's interactive, or simply delivering information. Simply imagine this is Facebook screen, real time, the feedback, something like that. And there could be series of interior design purpose post columns, okay? But those columns have screen, touch screen, or control devices, something like this, sequence of screen. So at first, actually I put the notes in this series of slides for making actual similar design visualization and representation. This is stage one, defining environment, defining universe. This is architectural environment, probably 6-7 meters by 10 meters, something like that. Human scale space, one single box, okay? So create a box and convert it into editable poly and delete one side wall because we need to place actually we don't need to remove, but just for your information, just remove one face and other sides supposed to be flipped. Actually this is box, surface model box by 3D Max, so only outside of the box is visible, inside not visible. But we need inside, so we need to flip, okay? Flip. Convert the face direction so that we can see inside. Let me show you in the lab exercise hours. And we need photometric lights. Placing light and edit light options and copy them. 3, 5, even 10 small lights for bright inside, okay? Change options. I told you most important thing is emit from, image shape, cylinder or sphere is good, not just point, okay? And take a look at, just test render to see the brightness. And then place a camera, okay? Target camera and adjust its location and lens focal distance so that you can see interior scene professionally, okay? And also, you can test render, change the view into the camera, and place given geometry, this kind of furniture or media post, and some window structure, frame structure, and so on. Easily you can modify in terms of geometric edit, okay? So this is camera view, okay? And you can assign texture map 1 polygon by 1 polygon if this is editable poly, not just a box, okay? That's why you have to convert it. I'm going to tell you how to select some of them, some of the polygons, and how to assign different material. So let's take a look at actual render scenes. No texture mapping here, nothing mapped. This is default material. But thanks to photometric lights, we can see it's looking professional or looking decent, okay? Next level, we can, this is not deletion, just assign different material in these selective polygons, looking like a media screen, okay? Also some additional structure, easily, simply copy and paste or instance copy, and generate some additional things, change light options, change the camera view, and test assign of the texture map as a media. So if it's not that effective, change the view, something like this, okay? And rotate texture map location so that it looks dynamic. Also, this is a sort of final view. Glossy surface, black color, stone material, and some media screen looking, touchpad looking object texture mapped, and floor object also looking realistic, glossy floor material, Autodesk material assigned. And this is the final render scene. Let me open the actual render image. Here it is. Okay. High glossy, because this is screen, so reflection and some partial reflection on the floor as well as on the surface of this post. Actually nothing assigned material to this given furniture, but anyway, this scene is looking something informative. What I mean is the design concept is media screen, media post for small IT-based company workers. And if there is a title or brief note, anyone can capture the concept and the objective or the reason why designers represent this kind of view. This kind of visualization can be generated by designers in a couple of hours, easily, okay? If you are very well trained, you can generate this kind of image in just 30 minutes. But the problem is this is very high resolution rendering. Let me show you this one, okay? Let's take a look at this image. Very high resolution, okay? Really high resolution image, actually, in UD, 3000 pixel and 2000 pixel. 10 hours for rendering this scene using my supercomputer in the lab. Expensive computer, not this laptop. That's the problem. So that is why today's lab exercise number 2, how to reduce render time, okay? 10 hours to probably 5 hours. Much better than 10 hours. Anyway, how to reduce time in high definition rendering, that's one of the topics today, lab exercise, okay? Okay, now it's time to move on to the lab exercise, okay?